we have to calculate stress A and stress B. So when we calculate our stress A, stress B, so this is equal to stress average plus or minus by a radius. So our stress average, all the numbers are all here, okay? Your stress average is equal to what? Equal to minus 16.977, okay? Minus 16.977 times 10 to the power 3 plus minus your radius is 22.179. So this will be equal to 16.977 power 3 plus by 22.179 power 3. So we have minus 39.156 times 10 to the power 3 psi. And the other one is 5.202 times 10 to the power 3 psi. Okay. Then from here, we can use the factor of safety, right? So the factor of safety will be equal to what is allowable, which is the stress yield, divided by stress A or stress B. You pick the higher value, okay? So this will be equal to the yield. Given to us, the yield is at what? The yield is at 42 times 10 to the power 3. And then divide by 39.256 or 156, I beg your pardon. Okay, I get rid of the sign because, I mean, if you want to put negative here, okay, you also have to put negative up here. We are fine with that. Why this is also can be negative? Because Vomesis assume that stress yield in tension is equal to stress yield in compression also. So the factor of safety divided by 39.156 is equal to 1.073. Okay, it's equal to 1.703. Okay. So now this is using Vomesis criteria. Okay. Now what I want to do next that is not asked in this question. Let's compare with Tresca criteria. So the thing to take note is the factor of safety is 1.03. Okay. And the torque that we can apply is 9.458 times 10 to the power 3 pound-inch. Now, the next thing that I want to do is we are going to now determine the torque from Tresca criteria. Okay, we are going to determine using Tresca criteria now. Okay, now whether we use Tresca or Vomesis, the Mohs circle is still the same. So we are going to do the same. Okay, so this is a very good term test question. Okay, term test. What am I talking about? This is a very good exam question where I make you compare the value determined from both what? Tresca and from also from who? From VC. Okay. So now we are going to use this for Mises now. No, Tresca. Okay. So quickly, we are going. So the mole circle did not change. Okay, I'd like to remind you, the mole circle did not change. Okay. So based on Tresca criteria, we know that tau max is equal to stress yield divided by 2. Okay. And this is equal to our radius. Okay. The radius over here is also the same radius over here. Okay. Also, it's the same radius over there. So we know that the stress yield in the question, okay, so the question, the yield strength is also equal to 42. So this will be equal to 21 times 10 to the power 3 psi. Okay. So to determine the radius again, okay, so this is so from 3D mole circle, okay, we know that the radius is equal to square root, okay, stress average squared plus by shear xy squared. Okay. So if I'm going to tidy this up a bit, we know that we are going to have r squared minus by stress average squared equal to shear xy, the whole thing. Okay. So from here, shear xy, now radius is still the same. Okay. So the radius we got is equal to 21 times 10 to the power 3 squared. The average stress calculated is the same as the average stress over here. So average stress will not change at all. It's equal to 16.977. Okay, 16 point. So equal to minus 16.977 times 10 to the power 3. Okay, times 10 to the power 3 squared. So now we compute the shear. I'm getting a funny number. 12.36 times 10 to the power 3 psi. So from here, we calculate the shear xy is equal to Ty over pi over 2 CQ. Okay. So therefore, the torque in the y direction is 12.36 times 10 to the power 3 multiplied by pi over 2 multiplied by C, which is equal to 0.75. About 3 times by shift pi divided by 2 times by 0.75 divided by 3 is equal to 8.191 times 10 to the power 3 pound inch. Okay. And then we have to determine stress A and B again, which is equal to the rate to the stress average plus minus by the radius. So this will be equal to minus 16.977 times 10 to the power 3 plus minus by 21 times 10 to the power 3. So this will be equal to 16.977 plus by 21 is equal to minus 37.977 times 10 to the power 3 and 4.023 times 10 to the power 3 psi. Okay. So from here, we can determine the factor of safety again. And this will be equal to minus 42 times 10 to the power 3 divided by minus 37.977 times 10 to the power 3. So this will be equal to 42 divided by 37.977 is equal to 1.106 factor of safety. Okay. So this is from Tresca criteria, and this is Tresca criteria. And if we were to compare with von Mises, this will be equal to 9.458 times 10 to the power 3 pound-inch. And this is from von Mises. And then the factor of safety is 1.073. Okay. So from here, we can make a statement that the Tresca criteria is more conservative. Yes or no? When compared to von Mises. And why is that? Because from Tresca, the top in the Y is equal to what? 8.191 times 10 to the power 3 pound-inch. Given the same diameter, von Mises, Ty is equal to what? 9.458 times 10 to the power 3 pound-inch. Right? So you can apply a higher torque with von Mises when compared to Tresca, and the factor of safety, okay, for Tresca is equal to 1.106, and the factor of safety for von Mises is equal to 1.073. Okay. So i.e., this one is what? Higher risk. Are we clear? When you tend to apply von Mises criteria, okay, we are in a domain, right? We are in a domain of higher what? Higher risk. Okay. So when to use what? Okay. So in the industry, what we tend to do, okay, it depends on the application. If we are designing, if this structure is moving and require fusing, right? We use what? We use von Mises. Because you want to put in, you want to maximize your torque. If it's designing something that is not moving, okay, like a building, okay, just a bit of twist, have fun with test stuff. Okay, so what we tend to use is anything that's what? You need what? Higher risk, low weight application.